On December 25th, 2021, from French Guiana in South America, the James Webb Space Telescope was launched, traveling 1 million miles to a precise location in outer space and then automatically unfolding, as in a miracle, a telescope that would change our knowledge of space and the great beyond. It's my pleasure now to introduce John Mather, Nobel Prize winner and the leader of the greatest scientific achievement in 2022, the development of the James Webb Telescope. Please welcome John Mather.
Well, good morning. I can't see you, but I know you're there. It's like stars in the daytime. So thank you for inviting me to come. I want to tell you the secrets of the universe, some of them. So the story I'm going to tell you is about the great James Webb Space Telescope, and named after the NASA's second administrator, James Webb, who was the man who went to Jack Kennedy with a plan for Apollo. He said, we're going to go to the moon, and we're going to do it not because it is easy, but because it is hard. And we're going to do that and the other things too. So when I watch the videos, I think, oh my God, what is impossible? So we are here, we are thinking about what is not impossible. All the things we could imagine wanting to know, we could know. So here they are. I'm going to tell you how we do it in astronomy. This great telescope is an international project of NASA with European and Canadian space agencies. It's taken 20,000 people to get it up there, and it's working beautifully. Thanks to those professionals who made it possible, and thanks to the backings of our governments around the world to do it. And it is available to every astronomer, every scientist in the world. You send us a proposal, and we'll think about where to point the telescope based on your ideas. So sorry for my voice, but anyway, there is the great golden hexagon in outer space. It is 21 feet across, that golden mirror. It is unfolded after it's launched because it's bigger than the rocket. An incredible engineering accomplishment, and it just tells us that nothing is impossible if you can imagine it. So imagine solutions. Thank you. So I want to tell you a little bit about why this is important to all of us. So where do we come from? I wanted to know that when I was little. I still want to know. What does we mean? Now it turns out we're not just sort of just entities. We are made up of 100 billion nerve cells, trillions of other cells, maybe many trillions of bacteria and viruses in our bodies. And they're all acting more or less independently, but cooperating until they stop cooperating. And then we go to see St. Peter, or whoever. So we can work on that question here as biologists, and people do. There's a new perspective opening up where we recognize that who we are is actually not easily described, but is based on information content, on DNA, on a social structure, on the organization of all those tiny entities. But we astronomers, we can work on the cosmic history. What did the atoms do? And are we alone? Is there some other place not too far away or far away where there could be life elsewhere? Of course, everybody wants to know, and right now we do not know of any neighbors, but personally I think they are out there. They may or may not be like us, but who knows, we have to find out. So is life a miracle? Well, for many centuries, people thought so. It required divine intervention. Now scientists are coming to think, well, maybe not. Maybe it will always happen given a chance. But how could we know? We have to go look. Well, how far can we go? Not very far, to tell the truth. We can get as far as Mars. And we can take pictures, though, and we can travel the entire universe with our imagination. So there we go. So how did I get started in this? This is my home when I was a child. I grew up on this little farm in far northern New Jersey, where my dad was a research scientist working on the genetics and feeding of dairy cows. So I got my science start by reading books and thinking a lot about the great questions, and I wanted to build telescopes. So now I do. So here is my first big project. This was something I did with NASA starting in 1974, right out of graduate school. And this is a thing called the Cosmic Background Explorer. We measured the Big Bang. We measured the heat of the Big Bang to see if it was the same everywhere, and it's not quite. And we measured its spectrum to see if it's really, as claimed, the residue of the earliest moments of the universe. So we started that not knowing how to do it. And by the way, it was the follow-on to a failed thesis project. My failed thesis project in Berkeley did not work right the first time, but these professional engineers made this thing work beautifully. And within days, we had the answer that we were hoping for. Yes, indeed, the story of the expanding universe is confirmed. So here is the thing that made us most famous. This got on the front page of newspapers around the world. This is the sky as seen, if you could see, with millimeter wavelengths. So this is the picture of the universe as it was young, when it was young, about 400,000 years old. And this is where we should start to be able to calculate what happened next. So if you knew all the right equations of physics and how to calculate, you should be able to say, from that grew the galaxies, from this grew the stars, from this grew the planets and places where people could live. Well, that's a big project, but we are working on it. So when Stephen Hawking saw this picture, he said that was the most important scientific discovery of the century, if not of all time. He had many reasons for that, but I would just say, if there were no spots in this map, we would not exist. So I guess it's important. So I got to go show my spectrum many thousands of times. Here I am getting my Nobel Prize from the King of Sweden in 2006. So I showed that chart a lot. So how are you going to know if this story that we're telling is correct? Well, you got to take pictures. Here's the great Hubble Space Telescope. It's 33 years old. It will be 34 in April. And when we launched it, it wasn't working right either. We had to send up astronauts to fix it. And it's been serviced altogether 5 times, which is a miracle in itself. Astronauts went up into space on the space shuttle. They got out in their spacesuits. They did things. They put in new equipment, got back in their space shuttle, and came home. So that's a miracle of its own. And when they did that, they said, by the way, we thought we were going to see the first things happening in the universe after the Big Bang, and no, we can't see them. We need a bigger, better telescope. So they wrote a little book, a very poetic little book called HST and Beyond. And from that, they said, please build us another telescope, which became the James Webb Space Telescope. So here it is, another picture of it. It's here a few words to say what we've got on board. We have instruments from around the world, from Arizona, from Europe, from Canada. We have a prime contractor, Northrop Grumman, near Los Angeles Airport and everywhere. We run the telescope from Baltimore the way we do the Hubble telescope, and I'll show you in a few seconds what we have found out with it. But anyway, it went up, as was mentioned, on a European rocket on Christmas morning 2021. So what did we find? Well, we built a telescope to pick up infrared light. Infrared light is the same as ordinary light, but longer wavelengths. And so you can't see it with your eye, but it tells us new things. So why? Well, here is a telescope picture from Hubble of a star being born from a cloud of dust. And that's very interesting. How are stars formed from clouds of dust? Well, you can't see it very well inside. You can barely see that right in the middle there's a new star with jets coming up. But if you could use infrared light, you'd see the star much better, because infrared light can go around the dust grains and see inside the clouds. So there's learning how our stars formed. Stars like the sun. We see cool objects that are not warm enough to emit their own light. And when we look inside, sometimes we see things we didn't expect. This is the debris of a star that's disintegrating as it's old. Stars come to an end when they're burn up all their nuclear fuel inside, and the sun will do that too in about 5 billion years. But don't worry, it's a long time away. It's called a planetary nebula because it looks like a planet, but it is not. And if you get a magnified picture, you will see inside there are actually more than one star inside, and we see a different structure. This whole amazing system has got 5 stars in it that are the cause of all this astonishing structure. So how do we interpret this? Well, very carefully. We draw stories, we make computer models, we simulate things in the computer just as you would do to predict the weather. We say it was like this and that will be like that based on the equations of physics. So here, this third reason why we want to study infrared light. We have the story that space is expanding, or another way of saying it is distant objects are running away from us at immense speeds, which means we receive light waves that come less frequently because they're running away. And that means we need infrared light to pick up distant galaxies. So here's the first thing we released in July of 2022, a picture we were very, very, very proud of. And I went down to the White House for this event. We see three things in here, three kinds of things. The stars are the ones with the 6 spikes sticking out of them, and we know about them, so that's not so exciting. Right in the middle are some extraordinary galaxies. As you know, a galaxy has hundreds of billion stars orbiting around a common center, and there are so many in there, so much material in those bright, fuzzy galaxies that they can actually bend space. Einstein told us that would happen, and so we say, okay, thank you very much. Space is bent. That means it has the ability to focus light from even more distant objects. So you can see in this picture curved pink objects, which are highly magnified and distorted images of extremely, extremely distant galaxies. So we're learning about the growth of the very first objects from the Big Bang. Oh my gosh, what a surprise to be able to see all those details. So astronomers are getting their wish, and we're helping us get our public wish of telling our own story. How did we get here from the Big Bang? Here's one of our surprises. Galaxies are not round when they're young. This is some of the most distant objects we can see, and they are long and stringy. And well, maybe we should be surprised. Maybe we shouldn't be, but we did not expect it. So I'll show it to you because this is a work in progress. Please explain that picture. Here's another beautiful picture. This is an ordinary spiral galaxy. You would have seen beautiful pictures like the Webb telescope, like the old pictures of spiral galaxies. Now this one we can see in infrared has a hole in it. The holes, or many holes in here, are due to the formation of new stars. When they're born, some of them blow up in a very big hurry, liberate huge amounts of energy, and they blow holes in the galaxy around them. So that's what you see here in the lower right corner and everywhere. So galaxies have holes in them because of gas pressure. It's the same way that sponges have holes in them when they are made. This is a picture we call the Pillars of Creation because it looks like that. And actually now we can see inside. Stars are being born. There are hundreds and hundreds of them being born inside this cloud. You can see there's a wind blowing through space. Just like that gas pressure I was telling you about before. The wind is blowing from the upper right to the lower left, and you can see the wind blowing around the objects in there, and even see this sort of reddish object in the right-hand side where new stars are being born as we speak. So these beautiful pictures need interpretation by scientists to say, how is it really working? But this is getting us to really, really understanding the details of our own origins, because stars like the sun are being born in there. Here is one. We're seeing a new solar system being born. You know, here in our own solar system, all the planets move around in a single plane called the ecliptic plane. That's where all of your astrological constellations are. If you were in this new system being born, the star is hidden right there in the center, in the middle of that hamburger bun, and you can't see the star, but you can see the light coming up and down. And if you were to come back in a few 100,000 years, you would be able to see the planets and the dust would be all gone. So a new star with planets, hopefully, some of them might be like our own planetary system. But on the other hand, despite the fact that we've been looking for a long time, we have not seen any other solar systems like ours, with 4 little planets in the middle, then a gap, then 4 big planets outside. So unknown how many planets are there that are like ours, but maybe a lot. This is a demonstration that we don't know what's going on. Pairs of Jupiters have been found out there orbiting around each other in the Orion Nebula, a place which you can see with your own eyes on a good dark night. This is the middle star in the sword of the constellation of Orion, and we are seeing amazing new things being born in there. Okay, on the next slide, I want to show you how that we find out about planets and their atmospheres. This is how we see if planets have atmospheres. When a planet goes in front of its star, some of the starlight might go through the atmosphere of its planet, and we'd see the difference. So we have measured that large planets have atmospheres and small ones don't so far. And we've seen at least 6 different chemical items in the atmospheres of those planets. So far, no little Earths are out there, but we didn't yet look in the right place. We know where to look, but we can't do it yet. So, okay, now I just want to show you a little bit of local stories. Here's good old Jupiter. And the great red spot is there, but it's not red because you can't see infrared colors with your own eyes. Anyway, all the big planets have rings around them, and this is a demonstration that Jupiter does too. We can watch the storms, we can think about the weather on Jupiter, and try to understand how the big planets work. Here is one of the places we're going to go visit. You see in the upper right corner is a little helicopter called Dragonfly. We're going to land out there on the satellite Titan, which orbits around the planet Saturn. This is a fascinating place. It's a satellite that has an atmosphere of its own, enough to fly a helicopter. It's cold out there, and there are lakes and rivers and rain and clouds and fog, and they're all made out of hydrocarbons like ethane and methane. And it's a place where you could imagine maybe there's another system of life as we do not know it. So we're going to go there and look and see can we pick up some samples? Can we look at them? Can we examine the surface, which is, by the way, made out of ice? Under the ice is an ocean, probably. So is it possible for life to be based on another system? We shall find out. Here's a beautiful picture of planet Uranus. Uranus is the only planet in the solar system where the spin axis is in the plane of the orbit, so it means we get to look down on the pole of the planet. So there it is, looking beautiful, and then as all the outer planets do, it has rings. It has many, many satellites. These are named after Shakespearean characters. And one of these days we'll understand how the chemistry of this system works. So why do you want to know that? Well, it's chemistry as it is not done here. It's informative about how to think about systems as large as the Earth, and clearly has some effect on our understanding of global climate change, global warming, all the things that are happening here on Earth. And we can test our understanding on things that are a little different way out there in the solar system. So just to wrap up here is the way that you can follow us on the web. There are websites all over which report our results. This week, there are new results that I get about how we are beginning to understand some of those mysteries that I showed you. So thank you very much for the opportunity to tell you this story, and there's much more to come after this. We are planning new telescopes to go up in 2027, eventually in 2040-something, a telescope capable of seeing, are there little planets out there that are like Earth, orbiting around stars like the sun? So nothing is impossible, so let's go. Thank you.